Okay, boys, we will start from now the third lecture of pressure and states of matter. And today we will discuss a topic which is written on the board. You can see the topic on the board. And the topic is combined object buoyancy math. So we will do some mathematical problems today. And we will use combined object. Combined object means a light object which has less denser than the liquid and a denser object than liquid, and these two objects are combined together, and we will release it on liquid, and we will see whether the object will float or the object will sink. Suppose you take a rod or a bar rod of iron and you combine it with a piece of wood, and then you release it in water. And we will do some mathematical problems whether this combination of objects will float in water or will sink in water. So these are the things we will do today's mathematical problem of buoyancy. Okay, first, when we will do this kind of mathematical problems, we have to know some conditions. We have to know some conditions. So first we write some conditions here. Number one, all of you should write this. To determine the combined object, whether it float or sink in a liquid, to determine for a combined object whether it will float or sink in a liquid, whether it floats or sinks in a liquid. Firstly, we have to determine their mass or density or volume. Firstly, we have to determine their mass or density or volume. Mass, density or volume. Turn off your microphone and just listen to the lecture. Mass, density and volume. So this is our first task. We have to maintain this condition. First, we will go for these three quantities for the both objects, the rod and the wood. For the both objects, we should go for these quantities first. Okay, number two. After that, by adding all the masses, we can get its combined weight. After that, by adding all the masses, we can get its combined weight. And after adding all the volume, we can get its combined buoyancy. We can get its combined buoyancy. We can get it combined buoyancy. So what we can say in the second condition, by combining mass, we get weight. We get combined weight. Okay. And by combining volumes, we get combined buoyancy. And when we get the weight and the buoyancy, after that, we can easily say whether the object will float or the object will sink. So these are the conditions we have to maintain. And this condition, if you maintain this condition, this type of math can be solved easily. Okay, so let's do some mathematical problems, then we can solve, we can go for this solve, how we solve this kind of math. So I am giving you one math. You start writing. An iron bar of 80 grams and 700 kg per meter cube density. Again, I am telling you, an iron bar of 80 grams and 7,000 kg per meter cube density is combined with a 200 cc wood piece, but a 200 cc piece of wood, a 200 cc piece of wood, which has density of 500 kg per meter cube, which has density of 500 kg per meter cube. 500 kg per meter cube. Full stop. If this combined object is released in water, will it float or sink? If this combined object is released in water, will it float or sink? So this is the math. So you are given two objects. First one is an iron bar, which has a density of 7,000 kg per meter cube and mass of 80 grams. So you start with like this one for iron bar. I have the mass of the iron bar as 80 grams. So you can say further as 0.08 kg. And it has a density, you can say the density ρ1 and mass m1. So density is 7,000 kg per meter cube. So you don't have any volume of this iron bar. But what we have that condition. The condition says that we have to determine these three quantities first. We have to determine these three quantities first: mass, density, and volume. So if any of these is absent, then we have to determine this quantity first. Here we don't have any volume. That's why we are going for this volume, the value of the volume. And how we can get it? We know that the equation is ρ1 as m1 by v1. So if I say v1, you can say it as m1 by ρ1. So what is m1 here? It's 0.08, and what is ρ1 is 7,000. So if you divided it, you can get the value of v1. And what will be the value of v1? Go for the calculator value and you can tell me, and I will write on the board. 0.08 divided by 7,000.
Sir, 1.14 into 10 to the power minus 5.
1.14 into 10 to the power minus 5 meter cube. So this is for iron bar, the volume. We have got the volume for iron bar. Just like this, we have another quantity here, and that is for wood. That is for wood. And wood has the volume. I am giving you the volume of 200 cc. So I can say it's as 200 into 10 to the power minus 6 meter cube. So this is the volume of wood. And also you are given the density of the volume as 500 kg per meter cube. So you have to determine the mass first, because the condition one says that we have to determine all the three quantities for the both objects. Yes.
Sir, the mass should be, sir, 0. Sir, it was 80 gram or 800 gram, the mass of iron.
80 gram. It's 80 gram. I have told 80 gram for iron bar mass. But I am not giving you any wood mass here. You have to determine the wood mass here. So how you can determine? It's
M equals to
so M2 is equal to rho 2 V2. Now multiply it and tell me what is the
0.1
value of M2.
0.1 kg.
Only 0.1. Okay, so it's 0.1 kg. So these are the three things we have got. We have determined the three quantities for the both objects, for the iron bar as well as for the wood. Now the second condition. What the second condition says? The second condition gives us that we have to get the weight by combining all of the masses, and we can get the buoyancy by combining all the volume. So here we have got two masses, one M1 and another is M2. So if I say the combination of mass, the combined mass, if you say the combined mass, then M should be M1 plus M2. So M1 is 0.08 and M2 is 0.1. So it will be 0.18 kg. That is for combined mass. And if I say the combined weight, so you will get the weight as mg. Only mg equation we will go for weight. So what will be the weight here? 0.18 into 9.8. You can go for weight.
1.764.
1.764 Newton. So this is the weight, combined weight. Okay, now if we go for combined weight, we can go for combined buoyancy also. So how we can get the buoyancy? By combining it on volume. So if I say the combined volume here, you can add V1 and V2. So V1, you have got 1.14 10 to the power minus 5. And also you have V2 as 200 into 10 to the power minus 6. So what you have got the combined volume?
2.11 into 10 to the power minus 4.
2.114 into 10 to the power 4.
2.114 into 10 to the power minus 4.
Minus 4 meter cube. So if I go for buoyancy, it will be V rho G, and it is the value of B. And the value of rho, because I am releasing it in water, that's why the rho is 1000 here, and G is 9.8. So what will be the buoyancy?
2.0, sir.
Only 2.0.
So 2.07,
sir.
2.07. Okay, I'll write as 2.07 Newton. So if I've got these two values, then I can compare it easily and I can say my decision whether it will float or sink. So if you look, W is smaller than F here. We have discussed it before that. When W is smaller than its buoyancy, the object will
float.
Sink or float? Obviously, it will float because
the object will float.
Is greater. The buoyancy is greater. The weight is smaller, so the object must float. Here, I am getting the decision that the object will float because its buoyancy is greater than its weight. In such a way, we can do some buoyancy math for combined objects. And this type of math, and we will get for higher order mathematics. That means you will get it on number 4. Number
Sir,
4.
sir, can we actually find out the density of the combined object by adding the mass and dividing that with the total volume?
Okay,
And
I'm
we can
telling you
also
that
solve that in that way too.
if I go for the combined density, the combined density will not be a solution. Because if you go for combined density, you will get it 7,500. And if you say that 7,500 is the combined density, then it is very, very greater than the density of water.
Sir,
So,
here I have found the combined velocity as 851.35 kg per meter cube.
Okay, if you say that if the total mass I have got and if the I divided this total number of mass by its volume and then the combined density I have got which is less than water, and I can prove it that the combined density is less than water, so it will float. That will be enough. That is correct.
Yes, sir. I was talking about that actually.
Yes, that is correct. That can be considered as correct one. But if we talk about the buoyancy thing, actually we are going to solve the W and F value. And that's why W, and if you determine W and F value, that means buoyancy value, and you compare it on this case, then that will be good enough. That will be good enough.
Question,
And
sir.
mixed density should be also the correct one. Okay. Okay, Ari, you can say me what type of question you have?
Oh,
No, sir. Iram has actually asked the same question, so it has been answered.
Okay, so this can be a correct one. You can go for combined density also, but if you go for this thing, I think that will be good enough. Okay.
Sir, in different places there is written that the density of food is 700 kg per meter cube. Which one is more accurate, the 500 one or the 700?
No, actually, textbook, you have the textbook value, which is the general wood, but there are a lot of wood. Some woods which sink on water. Some woods which float completely on water. So wood has different density. You cannot say all the wood has the same density. No, you know that the wood has some different structure, and with this structure, the density also depends on it. Some wood that sink underwater. So we can say that the wood thing, the density varies from 500 to 700. In this region, wood can vary its density. So 700, if you have the textbook on as 700 kg per meter cube, you should go for 700 kg per meter cube. But if you are given 500, you have to solve it on 500. Okay. So now we will go for a math. Now this mathematical problem you solve for me. Okay. So I am giving you the math. A stone has density of 5,000 kg per meter cube. A stone has density of 5,000 kg per meter cube, and it is tied with another object. It is tied with another object which has density of 800 kg per meter cube. Which has density of 800 kg per meter cube. Okay. If
Sir, কত বললেন?
800 kg per meter cube, it is tied with another object which has density of 800 kg per meter cube. If the volume of stone is 100 cc and the volume of that lighter object that means the second object, is 500 cc. What will be the condition for the combined object when it is released in water? What will be the condition for combined object when it is released in water?
Sir, can you repeat the last sentence, sir?
What will be the condition of the combined object when it is released in water? So you have to discuss whether it will float or it will sink. So that's why I am saying that what will be its condition? Either it will float or it will sink. So this will be its condition. You will go for it.
স্যার স্টোনের ডেনসিটি 5000 আর আরেকটা ইনফরমেশন কি ছিল?
আরেকটা ইনফরমেশন ছিল স্টোনের ভলিউম 100 সিসি।
ডেনসিটি 5000 না 500?
5000 ডেনসিটি ছিল 5000। Stone is actually made of, if you say that the soil has density of 5500 kg per meter cube, and stone belongs to this ground of earth. So that's why I'm telling you but giving you near about the density 5000.
Sir, what was the volume of the lighter object? 500 cc.
Yes, it's 500 cc.
And the volume of the stone was 100 cc.
100 cc.
It will sink in water.
That the object will sink in water because the density comes 1500 kg per meter cube.
1500.
The object will sink in water. So you determine the final conclusion by determining the density of it, right? Combined density.
Yes, sir.
Okay. So okay, we will wait for weight and buoyancy. The way I
5.8
I had a question.
buoyancy.
okay. So what is its weight? What do you find the weight of the
8.82
combined object?
Newton. Weight of the 8.82.
8.82
8.82 Newton, and the buoyancy you have found
5.88 Newton.
5.88 Newton. Okay, right? So its weight is greater than its buoyancy, so obviously the object will sink. Okay, so just give some time to others, and then after that we will go for another thing.
Sir, when we are asked to determine what will be the condition of the object in water, do we need to write it in the answer that whether how much of the object will float and how much will sink, or isn't it?
Yes, it can be also said. On the last map, you are saying that the buoyancy is greater than its weight. So if you have to determine this type of question, whether the object if the object will floating on the liquid, then you are asked to determine how much of the object will float and how much of it will sink. But if the object will sink, then you are not going to determine this kind of question, because the object will sink. It is fully immersed in water, so there will be no floating portion of it. So this is only applicable. The question you have asked me is only applicable for those objects which float on the liquid. And then you can go for how much it will float on the liquid or how much it will sink on the liquid. And we have discussed this type of equation before on our second class, right?
Yes, sir.
Okay. So the higher order question also can be like this. Okay, so the rest of us also have done this math. If any of us didn't do this, I suggest any of you who have done this math properly can give the screenshot in this messenger group, so that the rest of us can see the solution of it. Okay, so we will go for now the next topic. Have we discussed the Pascal's law?
No, sir.
Okay. So first I draw a diagram, and after that I am going to tell what a Pascal's law explains, and then we will go for some mathematical problems. But if we have time left, because we have only 13 minutes left, so moreover we can only explain the Pascal's law today. Okay, so first I draw a diagram, and you just draw with me, and after that I will go for Pascal's law and its explanation. Okay, just draw this diagram. I'm giving you 1 minute, and then I tell you about the Pascal's law. Okay, so boys, we have done it. Diagram we can show in this picture, and if we look into the diagram, we will explain about the Pascal's law from this diagram. But first, we have to know what is actually the Pascal's law. So first, here I am telling you about the Pascal's law. You will write it, and after that, I will explain it to it. Okay. In an enclosed system, if pressure is applied on a certain point of that system, the pressure will go, the pressure will distributed, I think the word will be distributed, the pressure will be distributed equally through the all section of the liquid. The pressure will be distributed equally through the all section of the liquid and will act perpendicularly to the wall of this enclosed system and will act perpendicularly to the wall of this enclosed system.
Sir, shouldn't it be liquid and gas?
Yes, it is for liquid and gas both, because it is for fluid. It is for fluid. Enclosed system for fluid. This is applicable for fluid. And if you talk about fluid, fluid is it has the existence of gas and liquid or both. It can be said as fluid. Okay, so what does a Pascal's law say?
স্যার আরেকবার একটু বলবেন স্যার, প্রথম থেকে মিলাই নিব ওটা প্রথম থেকে।
If a pressure is applied in an enclosed system, pressure is applied on a certain point of a system, it will distribute it equally through all of the sections and will act perpendicularly to the wall of the enclosed system. This is called Pascal's law. So Blaise Pascal was the inventor of it, and he invented that if you give some force, suppose this is an enclosed system which is completely enclosed with water, I can say that, or liquid, and I am putting some pistons here. These are the cross section of that system, and we have discussed it before that we are putting some pistons here, and these pistons have different area. If you look, this is the smallest and this is the largest, and this is the second largest, the third largest, like this way. So if I give, suppose I am giving F1 force through this small piston which has a very small area of A1, then for the small piston, the smallest piston, if I say what will be the pressure can be said as F1 by A1. So this is for the smallest piston. Okay, but this pressure, if I say this pressure, I can say it's P, not P1. It can be expressed as P also, because this pressure will go equally through all of the sections, like this one. This pressure will go equally distributed to all the sections. If I get 1 Pascal from it, then 1 Pascal pressure will go all the sections equally. And if this pressure goes through all the section equally, I can say if it is 1 Pascal, then 1 Pascal pressure goes on the right section, 1 Pascal on the left section, 1 Pascal on the down section. So the pressure will be distributed equally through the all sections. And if we look, the pressure will act perpendicularly on the wall of the each section. So if you say this piston, the pressure will act on the straight, that means perpendicularly it will act on that piston. So the piston will move in the backward region. All of the 3 piston will go in the backward side, or you can say in the backward region. Okay, so this is called the increase of force theory. How we increase the force? Because if I say this is suppose this is 1 Newton and this is 1 meter square, then I can say the pressure is 1 Pascal, right? If I say F1 as 1 Newton and A as 1 meter square, then the pressure can be considered as 1 Pascal. And I have discussed that this 1 Pascal goes through all the section of this container. Now what? For the second, if I say this is 2 meter square area and 1 Pascal for as pressure is applied on it, so I can get the value of F2 here. How? Because I know that pressure distributed equally, so I can make that for the second piston in this way, P as F2 by A2. Therefore, I can determine the force from here, F2 as P into A2. So if I say P as 1 Pascal and A2 as 2 meter square, then I can get just like this, 2 Newton. So for the second piston, I can get the value of F2 as 2 Newton. So again, if it is 3 meter square, because it has the different areas, then you will get 3 Newton for it. Similarly, if it is 4 meter square, you will get 4 Newton for it. So how the force is increased here? you just give 1 Newton force in a small piston of the section. The pressure is distributed equally, and this pressure will go for this big piston, and it will produce some big force on it. And that's why you will get the force increase, because you give 1 Newton, but you have achieved 4 plus 3 plus 2, 9 Newton from it. So this theory gives us how to increase the force by using the pressure.
Application of Pascal's.
I think you should say another. I didn't listen properly. Tell me the question.
Sir,
again.
can you please give us an example of a practical application of Pascal?
It's a real example. The practical application of this is your car braking system.
Like in what conditions or what procedures we can apply Pascal?
Yes, that is, your car braking system is the main application of it. Your car is heavier. It has lot of force or applied force when you are driving on it. Suddenly you get a speed breaker, and then you press the brake, and the whole car, suddenly you can stop that car by pressing the brake by very small applied force on it. You are giving you the brake on with your speed. It's a very small force, but the whole car stops with the help of this small force. How? Because all of these car's wheel is connected with just like of this big piston. And for this big piston, the force will be greater on that wheel. The wheel will get retardation, and then the car will stop.
Sir, does this whole inflow
using this
system,
Pascal's law, you can get it. Okay, then again, any question?
sir, does this whole inflow system have any name?
The inflow system has, in fact, no name, but you have to maintain the system as an enclosed one, because if you don't have an enclosed system here, then the system will not act properly. Suppose we call sometimes a car has fail in its brake fail করছে আমরা যেটাকে বলি. Actually, at that time, the system, the pipeline, there will be some leakage on that pipeline of the braking system. That's why all of the brake oil goes through that pipeline, and the brake is not properly working, and the car gets brake fail. So this enclosed system has no particular name, but we can say it as enclosed system for water, enclosed system for liquid or fluid. So this is the main theme here. Okay, boys. So we will go for the applications for Pascal's law on our next class. On that class, we will go the applications, the mathematical problems of Pascal's law, and other topics that we have left on the chapter 5. Okay, thank you, boys. Our class is over.
Assalamu alaikum, sir.
Thank you, and we will go for the next class. Thank you. Allah.
Assalamu alaikum.
Assalamu alaikum.